This is the 3.5 practice, page 210. Number 1, use the extrema to determine the minimum degree of f. So this is our f function, so we have 3, so it's going to be an x to the 4th equation. Okay, number 2, for g, there's 1, 2, 3, 4, so it would be an x to the 5th equation. Okay, give the local extrema of f, tell whether it is a max or a min. So AB is a max, ET is a min, and CD is a max. Number 4, G and P is a max, RH is a min, JK is a max, LM is a min. Number 5, the absolute, okay, describe all absolutes. Okay, so this one has an absolute. I'm not sure which one's higher there. I'm going to say this one is. AB is, and there's no min. Okay, there's no absolute min because it keeps going down, down, down. Okay. Number 6, the absolutes. There is no absolute minimum because this keeps going. There's no absolute maximum because it keeps going. Give the local and absolute extreme values of f. The actual values, the maximums outputs would be D and B. And the I think B is just a little bit higher, so B is the absolute max. You want all the extremes, so minimums as well. So ET, so T would be that output as a local min. Okay, so number 8, P and K are maxes, and H and M are the mins. Okay. Number 9. Okay, we just want to know, use the end behavior. So we want to know, is it up, up, down, down, or like this to describe the end behavior of the graph. Okay. So if you look at this, it's an x to the 3rd. So an x to the 3rd is not going to be up, up, or down, down. It's going to be a positive. So think about a positive slope like this. So it's going to be like this. We don't know exactly what happens in the middle there, but we know it's going to look like that. Okay. Now if you're actually going to write this out, we would say as x approaches infinity, right, to the right, f of x also approaches infinity. And as x approaches negative infinity, going to the left, it goes down, so it goes negative infinity. Okay, so if you write that out, it'd be like that. Number 10, we have a negative x to the 3rd is the basic of it. And if it's a negative x to the 3rd once again is up, down, or down, up, but it's going to have a negative slope to it, so it's going to be more like this. Okay. So if you write it out as x approaches infinity, f of x, okay, so if I go to the right, infinity, it's going down to negative infinity. And as x approaches negative infinity, our f of x, okay, negative infinity to the left, it goes up, so positive infinity. Okay, number 11 is a negative x to the 5th. Once again, it's odd, so it's going to go opposite ways. And since it's negative, it goes on a negative slope. Number 12 is an x to the 7th equation. So once again, odd, but it's positive. So we're going to go opposite this way with a positive slope. 13 is an x to the 4th. So when it's even, it's going to go up, up, or down, down. And since it's positive, we know it's up, up. Number 14, it's an positive x to the 6th. So once again, it's up, up. Number 15 is an x to the 5th. So it's odd, going to go opposite with a positive slope. 16 is, okay, so here it's a little bit mixed up, but our highest exponent is x to the fourth and it's negative. So it's a negative x to the fourth. So to the fourth and even, it's going to go up, up, or down, down. Since it's negative, it's going to go down, down. Okay, 17 is x to the 10,000th. So it's even, and it's positive, so it's going to be up, up. And 18 is a negative to this number, which is even. So even and positive is going to go down, down. I mean, sorry, negative is going to go down, down. Okay, so looking at end behaviors there. And in all of these, you can write them out as well. Like for this one here, as x approaches infinity, right? Infinity is to the right, it's going down. So f of x is going to approach negative infinity. And then also as x approaches negative infinity is to the left, it's going down again. So f of x is equal to approaches negative infinity. Okay, next problems, number 33. Okay, you want to match these up without a calculator. So just thinking about this, x to the third versus negative x to the third, and x to the fourth and negative x to the fourth, right? So x to the third is odd. Okay, so it's not going to go up, up, and down, down. It's going to go opposite directions. And since it's a positive, we're going to have kind of a positive slope to it. So 33 is D. Okay, 34, once again, odd. So it's not up, up, or down, down. It's going to go opposite directions. Since it's negative, it's going to have more of a negative slope to it. It's going to be C. 35, x to the fourth, up, up, or down, down. Since it's negative, it's going down, down. And 36, even, positive, up, up. Okay, number 37, once again matching it up again, which is the graph of x to the third. Okay, x to the third is going to be not up, up, and it's going to have more of this positive slope to it, right? So it's kind of, think about these down here, it kind of goes like this, so it's going to be choice A. 38, x to the fourth. Okay, it's x to the fourth and it's positive, so it's going to go up, up, which is choice B. Okay, how many real zeros? Remember, zeros are where it crosses my x-intercept, right? So it crosses my x-intercept one time, so there's one real solution there. Number 40, the graph of x to this one, negative x to the third, is either C or D. How do I know if it's either C or D? Okay. Notice it's x to the third. Notice this has 1, 2, 3, 4 turning points. So this would actually be an x to the fifth equation. Okay. So if it's only x to the third, it's going to be choice C. Which of the graphs cannot be a cubic? Okay, we know if it's up, up, can't be a cubic. And we also know that since this is 1, 2, 3, 4 turning points, x to the fifth, that can't be a cubic either. 42, how many positive real zeros does the function in D have? So looking at D, positive real zeros, remember our zeros are where it crosses the x-axis, but we want them to be positive. Okay, so zeros, it would have 1, 2, 3, 4 zeros, right? But how many of them are positive? We have 2 of them that are positive. Number 43, how many negative does A have? Okay, so in A, how many negative real zeros? So it has three zeros here. How many of them are negative? Just this one right here. 44 is the absolute minimum value of the function graphed in B, positive or negative. So in B, the absolute minimum would be this point right here, and the output is like negative 100, so that is a negative. .45, which of the graphs is a function whose range is not negative infinity to positive infinity? So range here goes from positive infinity and negative infinity. This goes positive, positive. This goes positive infinity, negative infinity. This goes positive infinity, negative infinity, right? But this one stops at negative 100, so it doesn't go down to negative infinity. So that would have a range from negative infinity through, negative 100 through infinity. Number 46, which is following is approximation for the local minimum point on graph A. So in A, we have local, what does it say, maximum or min? A local maximum would be this point right here, which has an output of, I don't know, a little bit less than 12. So it looks like it's 10. Okay, so it's this one and this one. And it's a negative x. So it'd be choice B. Okay, so you can see all those answers there. And if you need an explanation, go back and look at the listen to the explanations. Okay, number 47. Okay, true and false questions. Okay, the graph defined by this has 4 real zeros. Okay, so if it's x to the third, I can only have 3 zeros, 3 solutions, so I can never have 4. That's going to be false. Okay, 48. If I have this equation, it must have at least 1 real zero. Okay, now we didn't talk about this yet, but if you think about imaginary answers, we get those when we do like a quadratic formula, like plus or minus the square root of a negative number, right? So those are always going to come in pairs. Okay, so imaginary come in pairs. Okay, square root of it. When I get a square root of a negative number, I'm going to do a plus and minus of that. They come in pairs there. So if I know that there has to be 3 answers, and imaginary answers only come in pairs, I know there has to be one other answer that has to be real. So that's true. If a polynomial function of even degree has a negative leading coefficient, okay, so if it's an example like x to the 4th, even degree, has a negative leading coefficient, so it's a negative out front, and a positive y-intercept, and a positive y-intercept, so it increases, right? So we know it has to go, by the end behavior, has to be down, down, right? So does that mean that this function has at least 2 real zeros? So I know there's going to be 4 answers total, but does it have to have at least 2? Yep, it's going to have at least 2. Even if it's squared, right, it's going to have at least 2 because I know it's down, down. If it's 6, you know, we're going to have at least 2 of them there. Number 50. Okay, the function defined by 3x to the 4th plus 5 has no real zeros. I would say you graph that, but you can also think of it this way. If it's x to the 5th, okay, if it's an x to the 4th, you know it's going to be up, up, and this plus 5 actually just shifts it all up. So you know it's going to be here at 5. So is it ever going to cross your x-axis? No, it's not. So it has no real zeros. That is a true statement. No real zeros. 51. A function defined by this has 2 zeros. Okay, so if you think about this graph, it's a negative, so it's going to go down, down, and it starts at plus 5. So it kind of looks like this, right? Okay, so is that going to have 2 real zeros? Yes, it will. Okay, 52. The graph of this is equal to this, has exactly 1 x-intercept. Okay, so if you remember when we solved these, we set these, so cube it to the 3rd power just means there's 3 of them, right? So to solve this, remember how I just set them equal to 0? So I get x equals 1. So it really just has one answer. Even though this is an x to the 3rd equation, I only get one real answer from it. Okay, and they all are all the same thing. So number 52 is true. We only get that one answer from it. Number 53. Okay. Sorry if I haven't been looking up to see if I can get this all in the picture. Hopefully you get the idea as I talk through it. 53, a fifth degree polynomial, so x to the fifth, cannot have a single real zero. Okay, could you grab, so it has 4 turning points, right? Could it have only, and it has to go like this, right? Could it only go through the x-intercept once? Yeah. So it could only have one, so that's true. It cannot have a single, so false. It can have a single there. Number 54. An even degree polynomial, so let's say x squared or x to the fourth or x to the sixth, right? Something like that, must have at least one real zero. I mean, just think about x squared, right? If it's x squared, does it have to have a real zero? No, they could both be imaginary. So that's a false statement. And the very last one was number 74. Okay, we're talking about heating costs. In colder climates, the cost for natural gas at heating homes can vary from month to month. And it's given by this equation right here. The model is x is the month, so x corresponds to January, 2 is February, 3 is March, okay, all the way to 12 is December. Where do you think the absolute extremes might occur? Okay, think about that. The extremes are going to be the high and the low, right? So where do you think they're going to, this is the cost for natural gas. Where do you think the cost is going to be the most? Okay, in the coldest, right? So when is it the coldest? Maybe January. Okay, and where's it going to be the least? Maybe July, maybe August, depending on how you think about it. Okay, they say they use January and July, but somewhere around there. So if you have somewhere around January and somewhere around July, okay, those are going to be your somewhere around there. You could actually graph that in Desmos and see where it kind of comes out, but they're just kind of thinking it through. And what is the extreme of there? So in January, which is 1, right, month 1, if I take 1 and I plug it in here with this, okay, it comes up to be approximately about $140. And in July, which is month 7, if I take 7 and I plug it in here, I get approximately $15. So that would be the costs that we would approximate for the coldest month and the warmest month.